This is the Chapter 4 review, the proof section video. So we have question 28. To begin, if the median of an isosceles triangle is also an altitude, and then the triangle is isosceles. So we draw ourselves a triangle. I'll call it ABC. It has a median, causing these two to have a midpoint, causing those two to be congruent. It also has an altitude. So then we're saying that it's an isosceles triangle. So given would be that BD is congruent to DC and that AD is perpendicular to BC. We're trying to prove that AB is congruent to AC. Well, from our proof, we can do it as side, angle, side. We have the side BD being congruent to DC. We have the perpendicular piece, which causes, I'll call them angle 1 and 2. Angle 1 congruent to angle 2. And then we have the reflexive piece. So from the diagram, AD is congruent to itself. Bracketed together, we just proved triangle ABD congruent to triangle ACD, which then proves AB congruent to AC. 4 reasons. Reason 1 was if perpendicular, then two angles sup and congruent. 2 was reflexive. 3 side angle psi. 4 CPCTC. Question 29. AD is perpendicular to CD, causing a right angle there. Angle 3 is congruent to angle 4. And then these are perpendicular, causing a right angle here. We have side AD congruent to side BC. We're trying to prove that BF is congruent to ED. Well, when we look at the information that we have here, what do we know? This is a detour proof. We have the right angles, we have the sides, and AC ends up being the reflexive piece. So we can do HL triangle. The hypotenuse is from the diagram. AC is congruent to AC. We have the leg, which is AD being congruent to BC. And we have the right angles being formed from AD being perpendicular to DC and AB being perpendicular to BC. This one gives you a right angle at ADC, and this one gives you a right angle at ABC, which means that triangle ADC and triangle ABC are right triangles. Bracket it all together. We just proved triangle ADC congruent to triangle ABC. Once those are congruent, our whole goal is to get this side and this side. So what I would do is I would take angle 1 and angle 2, and I would take this side, and we could prove these two triangles by angle, side, angle. So from here, we can take angle 1 congruent to angle 2, and same reason, we can take AB being congruent to DC, and then we can use angle 3 congruent to angle 4, which was given. Angle, side angle, Reason 6, triangle ABE congruent, I'm sorry, ABF, change that to an F, is congruent to triangle CDE, which then we ran out of room, which proves BF congruent to DE. And we'll put that as a 5 because it's the same thing. Reason 1, reflexive. Reason 2, def of perpendicular. 3, def of right triangle. 4, HL. 5, CPCTC. 6, angle, side, angle, and we are done. Question 30. Right away, you notice P is the center, so probably a good idea to draw on the two radii. You know those two are congruent. You know angle 1 is congruent to angle 2, which is down here, which then, if angles, then these two sides are congruent. This causes a perpendicular bisector, which will cause those two sides to be congruent. So we can say from the diagram, reason 1, we can draw TP and PY. Then we can say that TP is congruent to PY. We also know that angle 1 is congruent to angle 2. That gives us TN incongruent to NY. This will cause us to have the perpendicular bisector. So PN is the perpendicular bisector to TY. And then from there, we can say that TE is congruent to EY. Reason 1, we got 2 points make a line. 2, all radii congruent. 3, if angles, then sides. 4 is 2 points equal distant, then perpendicular bisector. And 5 is actually, we're using definition of bisector to get the two to be congruent. 3 left. 31, AB is congruent to AF. BD is congruent to DF. Angle 1 is congruent to angle 2. Prove that AD is perpendicular to EC. Alright, we can prove that this triangle here is congruent to this triangle here by side, side, and the reflexive piece. So we got side, side, side. AF congruent to AB. FD being congruent to BD. And from the reflexive piece, AD being congruent to AD. This together gives me triangle AFD congruent to triangle ABD, which then we can state reason 3, angle 3 congruent to angle 4. Now we can bring in angle 1 and 2. We can add them to make them bigger. We could get angle EDA congruent to angle CDA, which if those two are both, we know that EC is is perpendicular to AD. And we're done! Reason 1, reflexive. Reason 2 was side, 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 which makes 3, CP, CT, C. 4, we did addition, make something bigger. And 5 was if two angles up and congruent, then perpendicular. Nicely done. 2 left. ED is a perpendicular bisector here, causing these two sides to be congruent and these two sides to be congruent. And I got the reflexive piece here. These two triangles are congruent by side, 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 which then left over for 1 and 2. So we got side, side, side. AD is perpendicular bisector to BC. This causes AB being congruent to AC. This also causes the other side of BE be congruent to FC, sorry, BF, congruent to FC. And then we got from the diagram reason 2, AF is congruent to AF because it's reflexive. Bracket it all together. Reason 3, triangle ABF congruent to triangle ACF, which then by CPCTC gives you angle 1 congruent to angle 2. 1 was if perpendicular bisector and 2 points are equal distant. 2 is reflexive. We've seen that a lot. 3 side, 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 which makes 4 CPCTC. And then there's 33. These two AB congruent to AD, DC congruent to there, which means that this is a perpendicular bisector. These 2 points are stationary, which makes DM congruent to there. What does this proof look like? AB is congruent to AD. BC is congruent to DC. These two together give me that AC is the perpendicular bisector to BD, which then states that DM is congruent to MB. Reason 1, 2 points equal distant, then perpendicular bisector. And reason 2 is if perpendicular bisector, then 2 points equal distant. There are your proofs. There's everything that you need. Good luck to you on the test.